Hey there, and welcome to 3D Printed FPV, where we talk about everything related to printing, building, and flying 3D printed aircraft and quadcopters. Hey, give me a subscribe or a thumbs up, would much appreciate that. I'm trying to grow this channel and need all the support I can get. I see a ton of airplane enthusiasts trying to 3D print airplanes, then complaining on Facebook, on Discord, Instagram, that they can't print lightweight PLA. Foaming or non-foaming, it is a difficult filament to print. All you have to do is follow this quick, easy guide. We're going to have a look at this, how to tune your printer up. First, we're going to print a temperature tower to select the proper temperature to print with. Then we're going to do some extrusion rate testing, some flow rate testing, and pick a flow rate. After that, we're going to do some pressure advance testing, input that, and then finally, we're going to do some retraction testing. This will get you in the best possible scenario to print lightweight PLA. All right, first step here is dialing in the initial settings we want. I've got the Creality K1 Max. We're going to go ahead and use that as our baseline. This is the actual baseline that Orca has in the system, unmodified. Next, I'm going to select my build plate, and I do have a textured PEI build plate. I've downloaded the lightweight PLA filament profile from Polymaker, and I've loaded that here. That's unmodified as well. And then I've got a process down here that is lightweight PLA V1. What this is Eclipson's recommendations for walls and top and bottom layers and infill. So there's nothing here that's outside of what we're going to do building these airplanes. The first step we want to do is do temperature calibration. So let's do a temp tower for this thing. And you do that by coming up here to calibration, you click temperature, and then you select the filament that you want. Obviously, we're working with PLA. We don't need to go up to 230. We can if we want to, but let's start at 220 and then run back down to 190. And what we're doing here, 190 is going to be the top layer of the print, and 220 is going to be the bottom layer of this print. I shouldn't say layers, it's steps as you're going up. It's doing the same thing on top of one another. And it's going to be taken down by 5 degrees C per unit that we're going up. So let me develop this thing and I'll show you what's going on here. All right, so you can see I've got this thing made, and I'm trying to get it where it's a little bit more readable. There we go. So this first object is 220 degrees, 215 degrees, 210, 205, all the way up to 190. And that's what we call a temp tower. We've got a little cone in here. We've got some geometry out here to look at. And then we've got this overhang here that is going to be tough to print. And perhaps the hardest part to print is this whole bridge going across here. This is extremely difficult for a lot of printers. So I'm going to go ahead and slice this thing. All right, slicing it up here. She is sliced, and let's just go through this one more time. There's my layers coming down. As I start to go up through the layers, all right, this is gonna kick off at 220, like I said, and then you can see it's starting to develop. Right there is that first bridge layer in the blue, and as we're going up, you can see after that bridge layer and then that top surface layer, it switches over to 215 degrees. We'll be able to see this in mainsail when we run this print, but as we go up and go up and go up, it keeps reducing the temperature, and we go from 220 to 190. All right, let's go ahead and slice this thing. I think I already did slice it. Sorry, it's talking too much. I've already sliced this thing. Let's go ahead and send this to the printer. My printer's networked, so all I've got to do is hit print and then say upload and print. And we watch this down here, and it's been uploaded and it's off to the printer. All right, I will put a time lapse of the print in the video, and then we're going to inspect this test article here in a wee bit. All right, as you can see, the printer is pretty much killing it here, racking out this temp tower. Just want to slow this down for a second and show one thing in mainsail. You can see here, if you look at the red graph there in the middle, you can see the temperature actually declining right there in the middle of the graph, and then on the far right-hand side of the graph for the first two layers. Just want to point that out. If you have mainsail, it's a great tool. If you don't have mainsail, I recommend installing it. Check out some of my other videos on how to install mainsail. All right, crew, we're back here with the temp tower samples. I was so disgusted by the first temp tower when I pulled it off. I actually printed another one. So we've got two towers here to look at. The first tower, when I pulled it off, you can just see all the stringing here, everything going wrong with this thing. I mean, there's like not one thing that's right, really. And in fact, when I pulled it off, I broke it. So I was like, oh, okay, well, I'll print another one of these. But boy, just look at the quality of the print here. Obviously, that lightweight PLA is tough to print and difficult to get right. I mean, the 190 is not looking good. 195 is not looking good. You can see the separation right through there. 200 is not looking good. 205 is not looking good. Nothing. And like I say, 220 might be the best layer as far as that goes. I mean, the bridge broke off of it when I pulled it, but if you look at the stringing, look at the things that are going on there inside the inlet and look at the top of the bridge, it might be the best layer that there was on that tower. So anyway, I was disgusted by that one and printed another one. And you can see this tower as well. It's not great, but the 220 and 215 layers have nice surface to them and pretty nice bridge to them as far as that goes. As soon as you get to 210, you start getting like a whole bunch of artifacts all around. Once you get 200, the stringing is just outrageous, crazy. And then as well, up here in the 200 range, I mean, there isn't even a pyramid or a cone whatsoever. And at least we've got a cone in here at 220 and 215. So if we take a look at these things on the overhangs, we'll just look at the one here. The other one fell over on me. None of the overhangs are, just like super tells in terms of like which temperature we should pick. Let's look at the backside here. Obviously, this looks pretty good. That looks pretty good. I'm starting to see some like layer lines in here as the temperature reduces, going up. So, and if we look at the deformation over on this side, I feel like once you get up in here, it's having some problems making the geometries right. I see some like under extrusions right through this area. So yeah, it's my recommendation that we go with 220 on this filament. I think I was printing at 220 beforehand, if I recall properly. I have done this before and dialed myself in the past, getting ready to print airplanes. So 220 is going to be the pick, and yeah, we'll roll on from there and start running the flow rate testing next and dial it on up, and then we'll cycle back and print some overall print quality tests. All right, crew, welcome back to the slicer. We're back over here in Orca, and first things first, what we need to do is come along, and we chose 220 degrees as our print temperature for this thing. For the lightweight PLA. So we need to come over here and make sure we're set up for 220. So I clicked on the pencil here to edit the filament, and I'm going to come down here to print temperature and look at nozzle. And sure enough, I've actually got 220 in here to start with. Yeah, this isn't the first calibration here. So 220 is dialed in both on the first layer and other layers. I don't need to hit the save button in my case. In your case, what I'd recommend doing is doing some type of add-on here of lightweight or problem maker plus calibration, dash calibration or something, and saving it. So you have both the baseline setting and whatever your values went to. It looks like in my case, 220 came as the baseline, and 220 is what we selected from the test article. So that's wonderful. Means they've put out a good, material setting guideline or filament guideline for their filament. So thank you, Polymaker. All right, next we're going to do these flow tests, extrusion tests. The first thing we've got to do is get back over to the prepare side. We're going to delete everything off the build plate. Then we're going to come back to calibration. We're going to say calibration. We're going to say flow rate, and we're going to do pass 1. All right, we want to discard everything. We don't want to carry over anything. Even though it says 220 here, if you've saved this, it won't do that to you. So I'm going to do a discard on this thing, pull over. It's going to take a second. It's going to build out these test articles for the flow rate test. Okay, so like I said, this is a pass 1 flow rate test, so it's going to make massive calibration adjustments as it's printing. Massive. Okay, so this test article here in the middle is 0. That's your baseline. 0 influence flow rate. If I go back over here to the left, this adds 5%, adds 10% up here, adds 15% right above the 0, and adds 20%. Then opposite, go in the opposite direction. So you minus 5%, minus 10%, minus 15%, minus 20%, run counterclockwise there. So this is going to add and take out a lot of flow out of the nozzle as we run this print. So remember, we've selected our temperature. Now we're going to run a flow rate test. So when we run this thing, what we're going to look for is each of these specimens, what their quality is. Then we're going to select the best specimen. So that's it. It's pretty simple. Let's take this thing and run this one off to the printer. First thing I've got to do is slice it. Looks like it's sliced up. Looks like it's going to take 38 minutes and 20 seconds to print here. I'm going to go ahead and run this to the printer. And I'll stick this in time lapse, and then I'll rejoin you to evaluate our test articles. All right, crew, I've got the build plate here from the first flow rate test pulled out into the workshop, and just taking a look at things here. So again, we've got the 0 adjustment sample here in the middle, then plus 5, plus 10, plus 15, plus 20%, minus 5%, minus 10%, minus 15%, minus 20%. So yeah, just taking a look at this thing, it's evident like real quick here. Minus 15%, you can see there's under extrusion all over the place. Even minus 20% is worse. Minus 5 is not looking so good there. So like the 0, the 5 over, and 5 under, I'd say the surfaces are pretty solid on those things, almost like no difference. A little bit on the plus 5, I can start to see some over extrusion. You can hear it when I stroke the dental instrument across there. You can hear the sounds. You can hear like less sounds there and less sounds there. So we might be somewhere like 0 and minus 5. As soon as we get up here to the plus 10%, you can just hear the noise there. And then you can hear and see you got a big over extrusion here, some globs along the side. And then once we get to plus 20 is just out of control. I mean, there's over extrusion all over the place. There's a burnt blob there. So we should be looking at the 0, or we should be looking at the 5 in terms of dialing this printer up. I'm going to go ahead and go with the, I believe minus 5 is what my choice is going to be here. So let's get back over the computer, do our math on the minus 5 versus the setting, and put that into Orca. Team, so we just had a look at our samples there, the test articles from the flow rate pass 1 test, and we came up with the fact that we wanted to use the minus 5 sample as our guideline. So the first thing we need to do is go and see what our filament flow rate is set at. So we go to filament, go down here and click the pencil icon, and if you scroll down past basic information to flow rate, there you have it. we're at 1.18 here. So 1.18, we're going to take 1.18 and move that over to the free spreadsheet that's provided below. If you can't do math very well, use a spreadsheet. We're going to start with 1.18 and go from there. All right, so we've got 1.18 in the spreadsheet here. All we have to do is come down here to best pass sample and put in -5. That was what we thought was the best sample out of our test articles that we just had. That's going to come up with 1.1286. So I'm going to put 1.13 back into Orca over here. And then we're going to print our second round. So 1.18 becomes 1.13, just like that. And I'm going to go ahead and hit the save button. I'm going to say save and done. Okay, so that's over with. I'm ready to rock and roll. Next, what I've got to do is come up here and run pass 2. So pass 2 is going to dial us in just a little bit more. Even better, if you can imagine that. So let's run pass 2. We're going to discard these changes. It's going to turn off here and burn out our next test article. So we've got from 0 to -7% test articles. We're going to run these, and then we're going to go back to our spreadsheet again and put this number and come up with our final flow rate adjustment factor for Orca. So let's slice these guys. Boom, sliced. So 42 minutes from now, I'll be back with you and we'll inspect these things. I'm going to put the print on warp speed for you so you can look at that and not waste your time. But yep, soon we'll be looking at this and making another adjustment from 0 to -7% and have this printer fully dialed up for flow rate. All right, it's time to print. And it's off and going. All right, crew, we're back out here in the workshop, and we've got these second pass samples ready for inspection. Having a look here at the 0 all the way back down to the -7. You can really see that the -7's got a good amount of under extrusion on it, and it slowly, gets worse as you get out here to 9. 9's really got some gaps in the -9. So obviously we don't want to go down that far. If we get back up here at the 0 has actually got just a tad of extrusion issues, and the -1's got a little bit worse. So, as I said in the previous segment, I was almost ready to go with 0 on the initial printer tune-up there, but we went with the, I think, -5, and, this is on the lower end of okay. I think I'd like to see maybe a little bit more there. So anyhow, I think we're going to go with 0 or -1 here. We're going to do -1 just for the example of the tutorial here, and jump back on the computer and adjust our flow rate correction factor using the free spreadsheet, and knock that out and get this printer tuned up for lightweight PLA. Here, let's go ahead and get our settings calculated for our findings on that second pass extrusion test. If you recall, we started off with 1.188 as our original setting. We selected the -5 plate on the first pass, which left us with 1.12. So our first pass setting was 1.12, and our best sample on the second pass was a -1. Or if it was a -5, you could put -5 in there. You can see that the final setting goes down even further. But let's do -1. And that puts us at 1.117. So let's call it 1.12. Will be our setting. So back over to Orca. We're going to go to the filament settings again, and then flow ratio and pressure advance and go to 1.12. And that's it. So let's go ahead and hit the save button on that. And the next step here, we'll be doing our pressure advance test. Let's go ahead and shut that. Let's go ahead and clear up build plate and go back to calibration again, pressure advance. Okay, here you got to select what type of printer you have. It's either direct drive or Bowden. I've got a direct drive extruder, so I'm going to select that. And I want to do a PA line test here. I prefer the line test over the pattern. I'm only going to do the PA line test here with the lightweight PLA. And we'll leave these as they are here. So basically, we're start pressure advance at 0, end pressure advance at 0.1, and go through steps of 0.002. So we'll hit OK to develop this thing, and I'm going to go ahead and discard these changes. They look identical anyhow. So it does something weird. It only does the PA test, like this text out here, until you hit slice all. And then once you hit slice, you actually get your pressure advance specimen. So what this is it starts drawing lines across here and accelerates as it does so, and it changes the pressure advance based on that and going through. So what we're going to do is inspect this and look for the best line and line quality that we have after this is done. All right, I'm going to throw this to the printer and carry on from there. All right, crew, we've got this pressure advance test article off the printer and out here in the workshop doing a little inspection on it. As you can see, starting down here at the bottom where pressure advance was 0, not even completing the lines. So you can see here it increases by 0.004 every increment going up. And it's not until we get up here in the 040 range, 050 range, where we actually start completing lines. So you can automatically rule out all these lower pressure advances. Only once we get up here to where we're actually completing lines is where we should be inspecting. So you can see the second, I guess, third of this test article actually has completed lines. You can see here this line, it starts off, gets thinner, and then breaks. This line is the first one that's complete and starts off the same width, goes across getting thinner and thinner and thinner, and then back. So that's you're starting to get into something that's working there, but not quite as dialed up as what you want. If we get up here to this line here, or this line here, you can see this thing's pretty much the same width all the way across here, and even into the other side of the line. And once you start getting above there, you start getting into some different shapes and some blobs and some narrowness. My favorite line is probably this line here, or this line here looks really nice. So that puts this right in, I think 084 is what it is. I know it's really hard to see on the video as the numbers aren't raised very far on the side, but that's 68, 72, be 76, 80, and 84. So 084 is what we're going to do with our pressure advance. So let's go back to Orca and get this into the system, and then move on to the next test. All right, crew, let's get these pressure advance settings back in the printer. First thing you do is come over here and click the edit button on your filament settings. Scroll down just a bit to the middle of the settings there, and you'll find flow rate and pressure advance settings. Go ahead and enter those. Enter whatever your test was, not what I'm putting on the screen, obviously. Go ahead and save that. As I've said before, I like to save a profile per test that I do and a profile per filament. That way I know what I've done to the settings and I know what I've modified. Okay, next we're going to do this retraction test. This is perhaps one of the most important tests that you can do. So the retraction recommended by Polymaker Varies whether you have a direct drive extruder or a Bowden extruder. Go ahead and look at those and set a range that starts at 0 and goes beyond what's recommended for your printer. I believe 3 is recommended for my printer, which is direct drive, so I'm going to go ahead and run out to 4.5. So you can see the test towers that are made here. Each one of those little rings represents a increase in retraction as you print going upwards. We'll have a look at this closer here. So it starts at 0 at the bottom, and then each little rim that you see there on the outside of the print is going to increase 0.1 millimeter on up to 4.5 millimeters or whatever we selected there when we made this test article. So yeah, no big secret there. Make the test article, pick off what your printer says, send it to the printer, and then we'll be inspecting this thing here in a little bit. Super important test. This is perhaps the most important test to nail down in the entire system. All right, crew, here we have it. This is our retraction test articles. As you can see, this is a test article we just printed there. You can see that the string on the bottom half of that thing is pretty rough. In fact, super evident. And then about halfway up the tower, you can see you get down to just some like minor telltale stringing. I'd almost call it like angel hairs or something. You can barely see them in the video. If I do stick my finger in there, you can maybe see them just a little bit better. Not much. Anyhow, remember we started this thing at 0 retraction and then ran it up to 4.5 millimeters retraction as we climbed that tower. So you can see about halfway through there is where we stopped stringing, and that should be our setting. Something maybe like in the 2.25 to like 2.5 range. Would probably put us about like right where my thumb is there, and that's where the stringing stops. So that's how you read that test article. One thing I did, which is interesting, is you can see that the stringing, started down here when we had 0 retraction, and then continued all the way up. I ran another test article and just started right at, I think 2.5 millimeters of retraction. And you can see here, because it started with no stringing, there was no residual stringing going on up the tower. You can literally, I can run my hand in there and nothing. So interesting to see. It just tells you the importance of actually getting the retraction settings right. Because if you don't get the retraction settings right in the beginning, that stringing just tends to like pull and pull and pull like all through your print. So like I say, you can see here, we started off with stringing. We still had residual stringing even after, the retraction was set properly. But if we started the print with retraction set properly, we got little to no stringing throughout the entire print. Anyhow, let's get back over and put these settings back into Orca and move on down the road. All right, flight crew, we're back with you over here in Orca Slicer. What we need to do is come and put this retraction setting back in. This is a printer level setting. This is why I named the printer differently for each filament. Obviously, your retraction is going to vary. So you go over here to the extruder tab. You come back down here to retraction, and I'm going to put in 4.5. I think that was the top end of our range here. This is where you need to put in whatever your test sample indicated for retraction. Again, I'd save that with a different name on it, so you know that this is set up for lightweight PLA. And from here, we're going to move on to the printer torture test. I love this test article I'm going to pull in here. Just have a look at this thing. It tests almost everything that you can think of on the printer. Geometry, overhang, stringing, bridging, and also gives you the ability to break out the calipers and check your actual print sizes. So you're going to make sure that those spars fit in your wings. You're going to make sure that things are printing right down to the scale that they're supposed to print. So you can see here, this guy's got a few towers on it to test stringing. It's got a couple of pyramids on it to test your print geometry. It's got some bridging tests on it that are various length. And it's got a couple circles where you can measure the inside and outside diameter on this. I am going to dial up the infill. The test article, I think, is made for 30% or 25% infill. I'll put the link for this test article in the description. It's a free download from Thingiverse. This is what all of your tuning should end with, is printing this or a similar test article. So if you look at the layers here, going down, let's get right down to the initial layer. There's not much drama going on in the beginning. Down here, obviously, just the beginning layer. You're going to see the bridging tests start to come in there on the right-hand side. The circles are already there to check your geometry accuracy. There's a bridging going on. And then we start these overhang tests. This overhang test also acts as a retraction test because you get stringing between those two towers as you come up, just like the stringing test that we just did in those towers. So that's it. Let's run this torture test and see how we turn out. I'm expecting a great outcome here. I think this printer is completely tuned up and ready for this torture test. All right, as I was watching this print, I couldn't help but chime in and say something. I was so happy with the print quality I was seeing in the K1 Max. I just couldn't keep my mouth shut. If you watch this thing, we're coming up. We're starting to get to the overhang pieces here. There's no stringing, or just minimal stringing going on between those two overhangs. That's indicative of that retraction setting that we made. And the print quality overall looks great. I can see inside, the bridging looks great. Just super happy coming into this. Let's go give it a good inspection. All right, crew, we are back and we have a micro test article here to look at. This is the final test after all of our printer tuning, and I am super happy with the outcome here. I mean, I'm actually proud of this. So if we look at this test article, first off, there's some geometries over here. These are extremely difficult to print with these narrow gaps in lightweight PLA. You can see that the bridging tests have almost worked out perfectly there. Again, very difficult to print with lightweight PLA. You can see that these bridging tests are actually just excellent. No stringing in there, not much, in terms of not laminated filament. I'm really happy with those. So the pyramid and the other tower tests over here, again, not much stringing at all in there. Super happy with those. Nice square geometries on those towers. You can see the two pyramids here, nice sharp points on them. I mean, this is about as good as it gets in terms of pushing lightweight PLA. So the overhang tests, you can see they printed pretty well, up to about 75% overhang, and we get a little bit of filament that's not fully bonded to the other layer inside there. Pretty well expected for lightweight PLA. I feel like you probably can get a little bit better results than that if you play with some of the overhang settings. You can see the surface here looked really well, up to about 60 degrees overhang. Same here, about to 80 degrees overhang on that. Super happy with that. You won't be able to see, but I did pull in the calipers and got on the geometries here. The geometries are within about 1/1000th of an inch of what they're supposed to be, or I guess that would be like 0.05, 0.5 or 0.25 millimeters. But yeah, within 1/1000th or two of an inch of what they're supposed to be. So those wing spars are going to fit perfectly in any holes that are printed, at least horizontally here. Anyhow, this is it. I'm super happy with this thing. I am ready to print some airplane parts. And next, we're going to throw some wing parts in the printer and see how we do with some Talon 1400 wing parts. All right. All right, flight crew, it is time to make the inspection on the wing parts we just printed after that printer calibration. These things are looking pretty beautiful, to tell you the truth. I'm super happy. You can see there's just a wee bit of, stringing there, but this is like angel hair stringing. This isn't like really, proper thick filament stringing. You can just see it's like dust just comes like right off there. So you can see that part is beautiful. There's a little like imperfection there and there. Those areas I've pressed on them and they are laminated together. The layers are stuck together. It has something to do with the infill. There's infill touching the skin right there. So, but yeah, nice looking part there. See this other wing part again. It's got some of that angel hair stringing on it, but you can see that stuff just comes off like dust. Looks real nice. And then that looks beautiful. Look at that leading edge. That is nice. Okay, so obviously the printer tune-up worked well. All you have to do is follow those steps. Start off, pick yourself a temperature. Do your temperature tower. Then do your extrusion, your flow rate testing. Do 2 passes of the flow rate testing. Do that. And do the pressure advance test, set your pressure advance, and then do the retraction test. Those are the steps. You're going to have great prints every time if you follow those steps. Please give me a like or follow, trying to join the elite of YouTube. No. Not trying to join the elite of YouTube. Just give me a like or follow. Would appreciate it. All right, Captain 3D Printed FPV is out.